Yes, so we're going to discuss hypothesis testing via this assignment C. Okay, let's take a look at assignment C, which is due in week 9. The first question says list the 4 types of hypothesis test studied. All right, assisted solution, the assistant is in week 9, page 1. Okay, so we go to the major Google Classroom. Okay, here is the code for it. Please take note of it. By now, all of us, right, knows the code, know the code. We go to classwork, right? And we are all familiar with this Google Classroom. Here you have the Math 1-to-1 information. Here you have the interesting readings, statistics application, all right, the project, okay. Information on the project. Project explanations, assignments A, B, C, and D, assignments A explanations, assignment B explanations. Okay. All that is there from the beginning. Assignment C explanations, we're on assignment C, number 1. So there's an explanation for number 1. Assignments D explanations, and we have the video. Okay, the question says week 9. So we go to week 9, you get in the video, you get in the PowerPoint, and you get in the PDF and the Word document. Okay, let's go to the PowerPoint, week 9. PowerPoint. Okay, if you click on PowerPoint, you'll get a PowerPoint presentation on the same week 9, page 1. Okay, wouldn't preview the file is right to preview. Okay, so it doesn't want to preview, so we just open it. Okay, it says too large to preview, so we don't have much time for the preview, so let's just go to the video. Okay, so these recordings, these videos are there prior to the ones that you are getting now. Okay, please take that in mind. And hypothesis testing, the classical approach.
This topic is named hypothesis testing.
All right.
In statistics, a hypothesis test
is a process that uses sample statistics to test the validity between 2 statements called hypotheses. So you must have a pair. You must have a pair.
Let's refer back to the term sample statistics. Sample statistics here means descriptive measures that came from a sample.
So please bear the difference between the word statistics and parameters. We did that in assignment B. What is a parameter and what is a statistic?
What is that word sample statistics? Because these are numerical values that came from a sample.
So numerical values that come from a sample are called statistics.
A population, which are called parameters.
And numerical values come out from a population are called parameters.
That come from a sample is called sample statistics. So hypothesis test is a process that uses sample statistics such as the standard deviation, the mean, to test the validity between 2 statements called hypotheses. Researchers in fields such as medicine, engineering, agriculture, geography, business, economics, psychology, sociology, finance, and many others rely on hypothesis testing to make informed decisions. Here, we will be discussing the classical approach to perform hypothesis tests and another method, the p-value approach, which is not normally discussed here. So here we'll be talking about the classical approach to perform a hypothesis test. Here are some key points that is worth note taking regarding.
Right, so you can get our answer for the first question right there. Okay, as you can all see clearly. All right, now let's go back to the assignment. State the purpose of each hypothesis test listed, week 9, page 6. Okay, so in that very same week, you can fast forward it. Okay, you can fast forward it and you can get the purposes of the, here it is, the purpose of the test. And you can also get that in the weekly note version, the PowerPoint PDF version of this, okay, of this video. Number 3, list and completely label the 2 symbols used for mean, variance, and standard deviation. So this question was in assignment B, and it is reiterated there because of its importance. Please note the difference between a statistic and a parameter. Please note the differences in their symbols, okay? For mean and variance, what is a parameter and what is a statistic? A statistics come from sample, parameters come from a population. So here now, when you make a claim, when you state a hypothesis, when you say something about the population, then you are talking about parameters, okay? But now, when you collecting the data, you're collecting the data using a sample, okay? And whatever calculation you do is called a statistic. Okay, so basically what you are doing, you are using sample statistics to verify population parameters. That's what is happening. Okay, that is what is happening. Always bear that in mind. That's basically what is going on. Okay, if you go to the beginning of the presentation, okay, when you state the hypothesis here, when you ask the research question, you're asking the research question about the population. What is the average height of Dominicans? What's the average age of St. Lucians? That's talking about the population. So when you answer that research question with a hypothesis, you are talking about the population. Now to verify that answer, to answer that question, to verify that answer, which is the hypothesis, or to answer the research question, you're going to collect data. So you would collect data using a sample, 30, 200. You're going to do all the organization, representation, and calculation, but your calculations come from a sample. So any calculation you do there is called a statistic. So you're using, so that's why they say, you know, using sample statistic to make decisions on the population. So bear in mind that is what is actually going on. No, that's the phase we are in now. Okay, hypothesis testing. We're using sample statistics to make decisions on the population parameters. Okay, so if you say the average age of Dominicans is 45 years, you're talking about the population. So that 45 years, that average year now is a mean. Okay, because you see the average age of Dominicans, so that's a population mean you mentioned, that's a mean. So to verify what you said, to verify the hypothesis, to test that hypothesis, a sample has to be collected and a mean has to be calculated here. So that mean now you calculate here now from the sample will be a statistic, it will be X bar. So note the difference between mu and X bar. So we're using X bar now to verify mu, if you want to put it that way. Okay, so please be aware of what is happening. So that's why I say now all the physical work, hard work has been done, if you want to put it that way, collecting, organizing, representing, calculating. But here now is more or less cognitive, it's more or less mind. Okay, so please be aware of what is going on now. We are using sample statistics, for example, X bar, to make decisions on population parameters, example, mu. Okay, so please always be aware that is what is actually happening now. Okay, and that's why that's the importance of reiterating that question of the symbols, to always know the difference between parameters and statistics. List the 3 pairs of hypotheses for a z-test for me. You can get that in week 9, page 6. Okay, so as you can see, assignment C, the structure of it is similar to the structure of the previous assignments. Okay, always bear that in mind. Number 5, state true and false again. Okay, this can be done. Number 8, number 7, from number 6, that's where we're going to start discussing. Okay, from number 6. So the worksheet has been prepared. Here it is. The worksheet has been prepared. And just like how we started on number 9 in assignment B, I think we started on number 18 in assignment A. We're going to start on number 6 in assignment C. All right. So that's where I made the changes. So if you see in number 6, it says Albert said that the mean score of students is below 90%. That's my worksheet. That's our worksheet. What says number 6 in the assignment? Albert said that the mean score student is above 80%. So whilst the assignment saying above, the worksheet is saying below. Okay, so know the similarities, know the differences. We're starting on number 6 in assignment C. Okay, bear that in mind. And the topic is hypothesis testing using sample statistics to make decisions on population parameter.